Hello, guys. Just wait for like more minutes, and then we will be starting. Okay, guys, let's start. So, welcome back. Let's quite small chapter in itself. Uh, that is for the distributed system. So, what I'll be doing, I'll be going through the exact slides what sir taught, but I'll be trying to be more descriptive uh, in explaining things, and I'll be extracting the important keys from all these slides so that it is easily understandable to you whenever you are again reading the PPT. So, is my voice clearly audible to you?
Yes, clear, sir.
Look, sir ne yaar Ashish bhai. Okay, so and PPT is also visible to you, right?
Right.
Cool. Let's start it without any further delay. So basically, distributed program like this is quite a small chapter, and every slide has having a particular unique content that is created. So first is we'll be discussing about what is a process. Okay. So as the content says, a distributed program is composed of a set of n asynchronous process p1, p2 to pn. So basically, if we see, we will have a process each time. Okay, so what will be the process we like? So the process will be whenever we see the time, it is like this: the process 1, and this is the process 2, and this is the process 3. So these are all the processes that we see: p1, p2, and dot 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 dot, we can say this is pn. So what is this doing? These are the processes that are been running onto our distributed system, and these processes are asynchronous in nature. Asynchronous meaning they will not run step by step. They will run with their timeline, and they means process will not wait for other process to complete. This is what asynchronous behavior is coming into picture. So I hope this line is clear to you. Coming on to the same second thing, these processes that we drawn here, okay, these processes won't be sharing the global memory, okay, and they will only be communicating with each other using message passing. So if one process wants to communicate with another process, it will share the it will send the message and it will receive the message. So sending and receiving will be the only mode of communication between two processes. And since they do not have a global memory, so it cannot happen that from process one something updates and on the process two it will directly be reflected, because there is no such global storage or memory shared that can help in this case. So this is the point number 2. Now point number 3 again says that the process do not share a global clock. Global clock meaning they do not run on single or same simultaneous time. And it will not happen that a thing will be that is changing here will instantly be reflected or accessible to the another process. So this is what the point number third says, that it does not share the global clock. Point number 4 is like process execution and message transfer are asynchronous in nature. So process execution is what it is. See, this is a process. This line is kind of a process. And why am I writing like drawing this line? Basically, after some slides we will be understanding a graphical representation, this one as you can see, which is time and space model. So whatever I am trying to do this here, this is basically corresponding to the time constraint here. Okay. And this upper arrow will be going for space for a particular process. So process P1 will have independent points or nodes that I'll be discussing later on, and this will go along with time, with respect to time. So what I'm trying to say is that the execution of P1 completely, and the message transfer between a P1 to P2, like for example this is the message transfer from P1 to P2. So this will be asynchronous in nature. Like it does not means that if complete process 1 will complete, then only the message will be passed. They can happen in their own time frame. Understood this point? Okay. Now the next thing is, without loss of generality, we assume that each process is running in different processor. Means we, as we told that they do not share global memory and they do not have a single processor. They all are running onto different processors, sharing information via only messaging. Now this is something important term. See guys, when we are studying this particular concept, right, this is, we know that this is a theoretical subject, so we need to keep hold on the terminologies that are being used, so that we do not need to reiterate over all the key terminologies that are used. So I'll write something here, Cij. So what is the Cij? This Cij is basically, C means a channel. Okay, C means a channel, and this channel is completely as a whole. This is, the channel is a group of all the processes that are happening. So they are, all the processes are happening into a particular channel. And what is this Cij meaning? Cij means that the channel, Cij denotes the channel from process Pi to process Pj, and let Mij denotes the message sent from Pi to Pj. So what this Cij means? Cij means that there will be a process Pi and another process Pj. So this Pi and Pj is basically P1, P2, P3, and so I and J will be falling into the category of 1 to n. Okay, understood this thing? What is this I and J? And Pi is corresponding to process 1, process 2, or process n, and similarly J also. So when Pi and Pj are communicating with each other via message passing, so what we will be writing here, I will be writing Cij as the communication between process I to process J, and Mij. Mij, see, this is very easy term to understand. Mij, M represents message. So message from Pi to Pj. So this is, since this is my, maybe this is my Pi and this is my Pj, understand for this thing. So any message in general situation, yes, any message that is passed from Pi to Pj will be called as Mij. Understood? Is it clear to all of you? Okay, I assume it is clear. So next point is important. The message transmission delay is finite and unpredictable. That means I do not know in prior how much time will be taken for message to be like sent from Pi and to receive to Pj. But it is finite, that I know, and that I know. It won't fall into the trap of infinite loop or something. So it is finite and unpredictable. I hope this particular slide is clear to you. Now coming to the next slide, this deals with the actions. Okay, now we have understood this line. Okay, this line we understood what is this. This is basically processes. Now we need to understand what this dots I am trying to make over. Okay, so let's understand this. So what it is being told, the execution of a process consists of a sequential execution of its action. So there is a process, right? There is a process. There is a process of everything, of making a tea or something. So it has some kind of action to do. Either we need to like burn on the burner, or xyz, many processes, like many actions are needed to complete a particular process. Similarly, in distributed system also, there are some sequential execution of actions are needed to come to be considered as an execution of a whole process. So these actions are atomic in nature, means they cannot be more divided or splitted. And these actions are modeled as three types of events. First is internal event, second is message event, and third is message receive event. So what are these three? I'll write here. The first one is internal event, second is message send event, and third is message receive. See guys, it is very easy to understand, right? So there are three types of event. If you see this, if this, so what is this event doing? Send event. Why? Because this particular node is doing the work of sending the message. Clear? What is this node doing? Can anyone tell it? Guys, am I audible to you all?
हाँ हाँ भाई, ऑडिबल ऑडिबल।
Yes,
Okay,
you are
cool.
audible.
Yes. So what this is doing, this second node is, this is basically message receive one. Okay, this is message receive then. So this, since this is message send, second one will be message receive. Okay, so these two types of events are happening, and this is an independent event, means it is not taking part into either sending or receiving. So this is called as the internal event. Internal event is like it is helping to for the execution of process without interacting with any other process. So there are three types of events. I hope you understand this. The first one is internal event, second is message send event, and third one is message event. Now let EIX denote the X event on the process EI. Now this events that I have made, I'll be marking them, right? How will be marking? I'll be marking this as E11, this will be E12, this will be E13, this will be E14, E15, and E16. What does it signify? It signifies that E11 meaning the bottom one is for the which process it's going on, and the upper one is for which event in that particular process is going on. So if I write E43, that means third event of fourth process will be marked. Is it clear to you all what this E68 meaning? It means
हाँ हाँ
sixth process will have eighth event. Okay, or I can say eighth event of sixth process. Is it clear? Cool. Okay, let's go on here. So this is now let's go further. So it says for a message, let send M and receive M denote its send and receive event. So if I write send MI, the MI, that means from PI there is been there is something to be sent, and REC receive M, that means something is received from the event. Next point is the occurrence of event changes the state of respective process and channel. Basically, whenever there will be like transfer of information or some internal actions happening, definitely there will be some change of state, and this change of state will be marked into the distributed system for further actions. So this is what is trying to say: the occurrence of event changes the states of the respective process and channel. An internal event changes the process at which it occurs. What is send? What is a send event? A send event changes the state of a process that sends the message and state of the channels on which it is sent. देखो भाई, send वाला क्या करेगा? First of all, point number one, it will send like it will update the send of that particular process. कहाँ से it is started to send? After it has sent, the point where it is received, the state of that receive event will also get updated. I hope this is getting clear to you. It is not tough to understand, just a simple term to understand. And similarly, the receive event changes the state of the process that received the message and the state of the channel on which the message is received. Understood? Is it clear till here? Any doubts? Okay, cool. Let's go further. So third wala slide is focused on the sequential ordering of that events. Like now we got the process, we got the events to be laid down on that process. Now what will happen with that? So the events of a process are linearly ordered by their order of occurrence. See, it cannot happen that E1 like this E14 occurs before E11, right? Only it will follow a linear sequential order in all the cases. So this is what has been explained in this particular thing, that event at a process are linearly ordered by their order of occurrence. The execution of process Pi produces a sequence of events E1 to Ex. As I told, a particular process will have number of events and each event will be lined up E1, E2, E3 till Ex, and that is denoted by hi. So hi, what it is? Hi is all the events occurring in that particular channel. Okay, so what is this small h denotes? The small hi is the set of events produced by a particular event, a particular process Pi. So this hi is basically all the events produced by that particular Pi, and this capital Hi is the summation of all the processes. So it is basically all the events happening in all the processes. If we create a subset of it, it will be equal to capital Hi. Okay, and now there comes a very important term to understand, this one, which this relation. So what does this relation say? It says it expresses a casual dependency among the events of Pi. See, this casual dependency, I'll give you a very easy example to understand what is this casual dependency. So for example, there is a process A and process B. If I'm making this arrow, now if change of state of A is affecting change in B, then I can say that A is casual, like B is casually dependent on A. मतलब क्या है इसका कि A is waiting for B is waiting for A to change the state so that it can change itself. That's what is the definition of casual dependencies. I have written it. I'll tell it where it is. Okay, in coming slides you will get to know. So now the send and receive events signify the flow of information between processes. Correct. To process for process to communicate, send and receive events will be very beneficial and important and crucial. So a relation this sign MSG that captures the casual dependency due to message exchange is defined as follows. For every message M that is exchanged between the two processes, we have send M, this what we can say forward symbol, receive M. So what I'm trying to say, see, I'll just explain to you this particular term, send M. So what it is basically, in a very basic term, it is trying to say, until and unless this send M will not run, this receive M will not run. Correct? Understood? Until and unless I do not send a message to someone, how will someone receive it? So it's trying to say this only, that for a message M that is exchanged between two process, send should be occurred first and then only receive should occur. So this says casual dependencies between the pair of corresponding send and receive is explained as follows. And this is what is written in this particular slide. Okay, understood ये वाला point, or is there any doubt in this?
यानी प्रोसेस ए
Yes.
मैसेज सेंड कर रहा है प्रोसेस बी को, तो जो सेंड है ए का वो पहले आएगा बी से, क्योंकि
हाँ,
पहले सेंड होगा फिर रिसीव होगा.
correct. So, like, see here, if there are two events A and B, and if this is the symbol, are you able to see what I'm trying to write? Yes. Okay. So, if this is happening, so it is very compulsion that A needs to be happened first. Until and unless A will not happen, B will not happen. This is what this arrow says. Understood? And this is what is signified here. Until and unless this send event is not triggered, till then we will not be able to see the receive. So receive is directly waiting or dependent on send to send the message. This is what is this arrow saying. Understood?
कैजुअल डिपेंडेंसी हुई ना ये भी.
Yeah, this is only the casual dependency. यही मतलब होता है casual dependency का. I have got it. ये वाली slide में I'll give you more insights of it. Okay. Coming to the next slide, now things are becoming more interesting because we will be more going into graphical representation and all. So we'll be going with this. The evolution of distributed execution is depicted by a space-time graph. Okay, so this is the space-time graph that is used to understand this. The above graph that I have drawn, A, P1, P2, P3, and all. This is basically the space-time graph which we are doing. Okay, so the horizontal line represents the progress of a process. Understood? Correct? The horizontal line that have been drawn here for every process, it signifies what is the progress of the process. Why it is progress? Because it is being measured with respect to time. So with something which is like represented with respect to time is like progress only. Okay, and the dots indicate an event. That dots that I created, right? If I create a dot here, this dot, this dot, this dot, this is also a dot, this is also a dot. Okay, so this all what are all this? क्या समझा हमने? This are all events. Now you understood what events are, correct? And this slant arrow indicates the message transfer. Whatever I'm like doing this basically signifies message transfer. So message transfer transfer from E11 to E21, correct? Got it? ठीक है. Since we assume that an event execution is atomic, on in the previous slide I told that it is indivisible. Hence, we can directly put a dot symbol to denote that it is a particular event that is happening in itself. In figure 2.1, for process P1, the second event is a message, and second and third event is the internal, and fourth is the message received. If you see this particular, now you will be understanding that E11 as a whole is not taking part in any of the message exchange, right? Not sending or not receiving. So what can be marked as E11? It is marked as an internal event, as it is internally doing some stuff for the process P1 to move ahead. Now, guys, can you tell me what this is particularly? If you are able to understand, this is basically message send event.
मैसेज सेंड हो रहा है.
Yes. So basically, E12 is doing message sending. Correct? E13 is again internal. Message 4. See, this one is a new thing. E14, what it is doing? It is receiving an event, right? Sorry, it is receiving a message. So this is message receive event. So what three events we learn in total? First is internal event, second is message send event, third is message receive event. And all these events you are able to see in this graph. I hope this is clear to you, correct? This graph is clear to you all, how the things are happening, how the things are working. Cool, makes sense. Okay, one thing I need to make you explain here. I'm sorry, due to some things that is gone green, but okay, I'll read it for you. So in the green like text, what it is written, it is defining the causal relationship, and it says if an event A causes or influences another event B, then B is causally dependent on A. That's what I explained. What I'm trying to say, that if there is something event A which is influencing or causing some changes into the event B, that I can say B is directly B is casually depending on A for some response. Now this relationship is crucial in distributed system to maintain consistency and ensure that events are processing in correct order. Okay, one thing you might have heard from sir also, the name Lampert. He many times he says. So there was a scientist named Lampert, and he created a relation name happens before. Okay, happens before का क्या मतलब है? Something is happening before. So A gives B. In terminology of Lampert, it says A is happening before B. Nothing more than that. This is what is happens before relationship. A causal dependency between event is often expressed using the happen before relation, which was introduced by Leslie Lampert. If event A happens before event B in a distributed system, we denote this by A arrow B. Okay, indicating that B is causally dependent on A. So I hope causal dependency, events, process, message send, message receive, and internal event. ये सारी terms are clear to you all. Correct? Shall we move ahead? Cool. Now coming to the next thing, casual precedence relation. Now all the things which will have casual are now casual for you all, because we have understood the concept of casual dependencies and casual relationship. Both are same in itself. So what is trying to say here? The execution of a distributed application result is a set of distributed events produced by the processes. Correct. The whole execution of that particular channel is a set, we can say, of distributed events that are happening in the process. Different events will accumulate together to complete a process, right? So what we are trying to write here, let H equal to union of hi. What is union of hi? I explained you this. What is this small hi? Small hi is basically a particular process having multiple events, right? Here, as you can see, this all the processes that I wrote, this all processes, this all will comprise of a one hi, and to sum all hi's, it will be denoted by capital Hi. I explained to you, right? So this is what is coming here. I'll just quickly go on to that particular screen. Yes. So this is what is shown. Capital H equal to union of all the HIs. Denote the set of event executed in distributed computation. Define a binary relation on set H as follows to represent this. Now, what it is written. See, this is very easy. This is very easy to understand. I like today understood by sir. So it says for all EIX, for all EIX and for all EJY, if EIX is said to be EYJ is said to be casually dependent on EIX if it says if I equal to J and X is less than Y. Do not worry what it is, I'll just give you a nutshell. See, I am trying to make a relationship between these two. Okay, or let's not make it more difficult, let's do it here. Okay, yes, this one. Okay, so this is my one event and this is my another event, correct? अब एक बात बताओ, in this case what should be the constant? This lower time. Why? Because they both are of same process. So in this case I and J should be equal. That's what is given. I equal to J. And upper thing, see, this is basically I comma J and upper is X comma Y. Okay, understood. So what it is trying to say that I should be equal to J, meaning they should all be of same process, and X should be less than Y. What it is trying to say, that E31 should be like, it should be less than, means the event E13 should have occurred before E. That's why it is in linear order, right? Agar E23 pehla ho gaya, so it won't be a synchronous thing, or it won't work like that. So this is the two conditions, and with an AND operator, that both are mandatory. So guys, are you able to understand this first condition? That first of all, both should, this I equal to J, meaning both should belong to a same process, and X should less than Y, means that event 1 should be occurring before event 2. Correct? Understood?
Bro, can you repeat in short?
Yes, this one, this condition only.
नो नो, ये पूरा कैजुअल प्रेसिडेंस रिलेशन है ना, एक शॉर्ट
हाँ हाँ
कैजुअल वे में बताओ.
हाँ हाँ. Okay. So what is this causal precedence relation? It's basically, it is a summation of all the basically events that are happening. So H, capital H is equal to union of small hi's. Small hi, each small h is representing all the events of one particular process, and all the events of all the processes is equal to capital H. Understood? Okay, cool. Now this EIX gives EJY when it will be true if it follows the particular condition. First condition is that I should be equal to J, meaning they should be of same process, because I and J meaning this one. And X should be less than Y, means if this is X and this is Y, X should have occurred before Y. उल्टा नहीं होना चाहिए, then only it will work. Understood? Okay, cool. The next condition is ex should be like message ey. So if we are writing a message here, it says message passing. So but obviously अभी मैंने आपको बताया था कि sender should be occurring before receiver. It cannot happen practically, and it is a law also that e receiver cannot happen before e sender. So e receiver will always wait for the sender to send the message. And third one is transitive dependency. So let it be for now, it is not for that useful, but I'll take this later on. There is some like derivation more short where it is required. Okay, this is again that particular theory only. And the third condition that I told, this is basically a transitive relationship, that's here. The transitivity condition state that if there exists an intermediate event ezk such that eix gives ezk and ezk gives e, then ei happen before this. So basically what they are trying to say, I'll just summarize you. Okay, there are three lines, 1, 2 and 3. Okay, so if this is happening, okay, and this is happening, sorry, let me take it back. Okay, and this is and this is happening, then in this case this can be a transitive relationship. How this can be a transitive relation? This is sending the message to this is sending the message to this, and this is sending the message to this is valid. But what not is valid? If let's draw this thing, 1, 2 and 3, if this is sending the message, अरे यार, अब ठीक है. Yes, if this is sending the message to this is sending the message to this, it should not happen that this is going backwards. Okay, backward nahi chalega. That's what is trying to explain. That this event should not occur before this event. This particular next new event J1 should occur only after this. This is what is trying to say here. See this. This ensure that EXI, EZK, EZK, EY, it should happen before E. Understood this point?
यस भाई. यप.
कूल कूल कूल. अब आगे चलते हैं. तो सी गाइस, अभी जो हमने अभी तक समझा ना, वॉट एवर वी लर्न, दैट्स all is written in this. So I'll be reading it for you. You will definitely get understanding of it. So point number 1 is, note that the relation this gives is nothing but Lampert's happen before relation. Yes, understood. For any two events ei and ej, if ei gives ej, then ej is directly or transitively dependent on ei. Correct? We understood this. Graphically, it means that there exists a path consisting of message arrows or process lines along with increasing time in the space time graph that starts from EI and completes to EJ. So what it is trying to say, that if I am trying to say कहाँ गया मेरा, yes, ये मेरा अगर EI, ये मेरा EJ and this is my EK. So if I write EI gives EK, then either K is directly dependent on I or K is transitively dependent on I. So in this case, K is transitively dependent because this is coming in two ways, this first way and this second way. So this is transitive relationship. But if I write EI gives EJ, then this is a directly dependent or casual relationship. So this is how this has been written. Okay. So it is also, there is also given that, for example, E11 is E33. So what it is coming here, E11, this one and E33, correct? These both are transitively. Why transitively? Because if you can see, there is a path in this. There is a path, this path 1, path 2, 3, 4 and 5. I am able to reach E33 from E11 using this transitive relationship. Hence, we say that they both are this. And similarly, E326. This you can check later on. Then the relation this denotes follow the flow of information in a distributed computing, and EI gives EJ dictates that all the information at available at EI is potentially available to EJ. देखो भाई, what is happening is, जब हम ग्राफ ये देखते हैं ना, तो यहाँ से यहाँ मैसेज पास हुआ, फ्रॉम हियर टू हियर मैसेज इज गेटिंग पास, दैट मीन्स इंफॉर्मेशन ऑफ स्टेट इज गेटिंग पास. सो ई के विल गेट ऑल द अवेलेबल स्टेट इंफॉर्मेशन from ei. Basically, the ahead the events are moving, all the events will get the information of their past events. This is how things are working, and this is what is written here. If you can see where it is here, it says the relation denotes flow of information in distributed computing, and it dictates that all the information available at EI is potentially accessible to EJ because EJ is dependent on EI to get the information. Got it? समझ गए? Shall we move ahead? Guys, yes, no, yes, no, yes, no. Cool, 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 cool. चलो, अब है ना ये वाला, let's see this. What is this? Negation. Okay, so if such condition comes for if in front of you, EI, EJ, what is this? Basically, if I say this means EJ is casually dependent on EI, so what can be said for this? EJ is not casually depending on EI. Means EJ will never know what is the state of EI. That is, EI and EJ are never in contact with each other in any of the path. Let's go above and check, is there anything sort of thing that is happening? See guys, can you check this E12? Let me use another pen. Yes, can you check this E12 and E13? Can you quote that there is any relationship between, like any path between them to communicate with each other? Can you see any?
No.
No. So if you cannot see any path between
Yeah.
them, that means they are not casually dependent on each other. Or I can say they are concurrent in nature, because they are running parallelly together, right? They are not waiting for each other, or they are not in any dependency. They are independent from each other and they are working on their own. So this is what is written here. कहाँ गया ये रहा. For any two events EI and EJ, if EI is not casually dependent on this, the fact denotes the fact that the event EJ does not directly or transitively depend on event EY. That is, event EI does not casually affect event EJ. I hope a very simple English and very understandable facts to like to cover. Next point is, in this case, event EJ is not aware the execution of EI. See guys, in this scenario, since EI and EJ, they do not have any direct communication or connection, this E13 will never get to know what E12 is doing or what is the state of E12. I hope you are able to understand this thing, right? Correct? So this is
Yes.
what is written here, that in this case, event EJ is not aware of execution of EY or any event executed after EI on the same process. Understood? So in the figure also, that this case I just show it to you just now. Correct? And note the following rule, just to more as like understanding things. EIJ does not imply that EJI, like it, I'm saying that if this and this, if if this is not dependent on this does not signify that this is not dependent on it. Okay, you can work around it later, it is not that important. But yeah, if you face some issues, I'll be there to help you, because I have that understanding, so I'll be in the position to help you in that case. Okay, so the term I used just 2 minutes ago, that if two of the events are not in any contact with each other, casual dependency or transitive dependency with each other, they are concurrent events, because that they are working on parallel mode. So for any two events, if EI is not dependent on if EJ is not dependent on EI and EI is also not dependent on EJ, both the cases should match. Then in this case, we say that the events EI and EJ are said to be concurrent. Understood this thing? Understood this thing? So this case I just explained to you right now, E13 and E33. If you want, I can show it to you again. Don't worry. E13 and E33. Where it is? Sorry, E12 and E13. क्या था वहाँ पे, मैं भूल गया.
वो तो E13 and E33.
Yes, and E24 and E13. Let E24, where it is, E24, E24 and E33. See this. See this E24 and E33. Do they have any direct communication? See, you cannot say that this is the communication, because E24 has happened after this. So there is no such communication between this, right? So E33 will never get to know what is happening to E24. Similarly, E24 can never understand what is happening to E23, because there is no communication from this to this. अगर यहाँ पे line बन जाता, if this line would have created, then it would be in the position that it knows. But in this situation, there is nothing sort of thing. Understood this thing? So they both are hence working in a parallel mode. The relation, this is not transitive. That is, if EI is concurrent to EJ and EJ is concurrent to EK, that does not signify that EI is concurrent to EK. ठीक है? Clear है? Guys, is it clear?
एक डायग्राम समझा दो.
What?
ट्रांजिटिव वाला. ट्रांजिटिव वाला.
ये वाला लास्ट थर्ड पॉइंट.
हाँ, यश ये वाला फिर से एक्सप्लेन कर दो ना, ये वाला पॉइंट.
थर्ड वाला ना.
हाँ हाँ हाँ.
हाँ देखो, इसको एग्जाम्पल से देख लेते, नीचे एग्जाम्पल भी दिया है. सी, मैं बताता हूँ आपको क्या कहना चाह रहा हूँ. आई एम ट्राइंग टू से, इफ देर आर टू इवेंट्स, यस, ओके, यस, if there are two events, ei and ej, if we are saying, and if we say, and there is event ek also, if I say ei is concurrent to ej, concurrent का क्या मतलब है, that ei is not depending on ej and ej is also not depending on ei, then they are concurrent. So I am saying if ei is concurrent to ej and ej is concurrent to ek, then traditionally क्या दिमाग में आता है, that means ei is concurrent to ek, right? This is the basic thought, but in this case this does not happen. That's what is written here, that if ei is concurrent to ej and ej is concurrent to and operator ej is this, that does not say ei is concurrent to ek. Let's explain this using the example. Okay, so what is the example? It says e33 and e24. Let's plot it. So where it is, e33, here e33 and e24. Okay, so they both are concurrent, right? Correct, guys? Just give me a heads up. Are you able to understand this?
Yes.
Yes, right.
Yes. So E33 is concurrent to E24. Understandable. Now E24 is concurrent to E15. Now E24 is concurrent to E15. Correct? hai? Yes. E24
हाँ
is concurrent to E15.
Right.
So can we say E33 is concurrent to E15? सोच के बताओ. नहीं बोल सकते. Why? See, from E33 the path exists, this path exists, the path exists, and the path exists. Correct? So I can reach from E33 to E35. That means E33 and E15 are not concurrent to each other. So this is what is been explained in this. Understood now?
हाँ क्लियर है.
Cool. Great. Yeah, now it is same, that that is only written if ei is this ei or this execution. ठीक है, nothing much to worry about in this. ठीक है, I hope you are able to understand this till here. Okay, I would gladly say that 50% of the chapter 2 is completed till here. Okay, चलो, let's move ahead. कितना टाइम हो गया? We have 30 minutes more. Let's try to wrap it up. So there are two types of concurrencies. Now we are coming on to the concept of concurrency. I told that each slide will have a single topic to discuss. This will be concurrency. So there are two types of concurrency, logical and physical. What it is? In a distributed computation, two events are logically concurrent if and only if they do not casually affect each other. Okay, so basically all the concurrencies are logically by nature. Okay, but what is physical concurrency? Physical concurrency, on the other hand, has a connotation that the events occur at the same time, like at the same instant in the physical time. That means two processes are working, and this both are happening on that same unit of time. If this is my time graph, and this is my, let's say, 2 unit of time, unit can be anything. So these both are happening on the same instant. This is known as physical concurrency. Okay, moving ahead, you will understand it more better. Two or more events may be logically concurrent even though they do not occur at the same instant in physical time. Correct? ये तो आपने फर्स्ट लाइन में पढ़ा, that two or more events can be logically concurrent. Basically they are logically concurrent, right? However, if the processor speed and message delays would have been different, or I can say if the processor speed and the message delays are in ideal scenario, then time will be same only. Correct? That's what is written. Then the execution of this event could have been very well coincided with the physical time. So whether a set of logically concurrent event coincides in the physical time or not, that does not change the output of computation. This is the assumption that is made. We are assuming that in ideal situation, this any set of logical concurrent event, if they are colliding on physical time or not, that does not make any difference on the outcome of the computation. Therefore, even though a set of logical concurrent event may not have occurred at the same time, we assume that they are happened on the same time. ठीक है, समझ गए? I was asking sir today this question, E12 and E13. He also quoted this, that this graphical representation may be wrong because we cannot exactly plot where the E1 and E1, this one and this one has happened. They may happen in the same line, they may happen different. So ideally we take that they all have happened on the same instant of physical time. Is it clear to you all? भावेश, अंशुल, चंद्रबान, अदर गाइस, सब लोगों को समझ में आ रहा है क्लियरली?
हाँ clear है.
Yes, bhai. Yep.
Cool. Great. Moving to the next thing. This is another set of new topic to like learn. Models of a communication network. Okay. Okay. So there are several models of the service provider by communication networks, namely FIFO, non-FIFO and casual ordering. देखो, this is very basic क्योंकि हम लोगों ने पढ़ाई है बचपन में. I'll start with this. FIFO means first in, first out. Okay, so in FIFO model, each channel act as a first in, first out message queue, and thus message ordering is preserved by a channel. See what it is trying to say, that the first message, see देखो, I'll give you a real time example. Okay, so I have Bhavesh's name in front of me. So if I am sending a WhatsApp message to Bhavesh, okay, and I send 8 messages, or I can say images. Okay, images. If I share 8 images as in a one go, what will happen? Bhavesh will get randomly arranged images, right? Correct. हो सकता है कि image one that I have sent on 1 millisecond may have received later on, और बाद वाला पहले आ गया. It can happen. But what happens in FIFO is, in FIFO the first message that I have sent, it will be received by Bhavesh first, and later on the second message that was sent, it will be received by him. So this is FIFO, first in, first out. First message to be sent is the first message to be received, and the later on. And in this case, every time the order will be maintained, because I will be in the impression my order of sending will be equal to the order of receiving of the second person. Correct?
तो एक एग्जांपल हो सकता है टिकट काउंटर का, जैसे जो टिकट की लाइन में आगे खड़ा है पहले उसको मिलेगी, उसके बाद
Yes,
दूसरे को
correct,
मिलेगी.
correct. Ticket counter, if someone is standing in the ticket counter line, so the first person who will be buying the ticket will get the ticket first, and it will not go in random fashion. I hope you got real-time examples of FIFO, and this is how it is working. Now coming of non-FIFO. So same, non-FIFO is like batch processing. If in the non-FIFO model, a channel acts like a set in which a message sender processes, adds message. The sender adds the messages one by one, one by one, and the receiver gets it in a randomized manner, and he just remove that message from his queue to mark that the particular message has been received. This is non-FIFO. And third is casual ordering. What this casual ordering is, casuality, this, yes, here it is written. Okay, I'll take a minute. Okay, so casual ordering is, what is casual ordering? It is slightly different from normal ordering. What it does is, it uh, orders on the basis of casuality. Like if A is casually dependent on B, and B is casually dependent on C, so until and unless this is passed to this won't pass to this. Correct? Understood? This is what is being told to this. Understand this. Casuality. In this model, the order of messages, I am reading this thing. Okay, in this model the order of messages is determined by the casual relationship between them. If one message is a result of another, then the first message must be received before the second one. That's what I'm trying to say. That if, for example, if this is a person 1, this is a person 2, this is a person 3, so until and unless B will get the information from A, C cannot get the information, right? So this is what is casual ordering meaning. Okay, so casual ordering model is based on Lambert's happen before relation. The system that supports the casual ordering model should satisfy the following property. See, it is very easy. What it is? Send MIJ. MIJ का क्या मतलब होता है? M is message, I is passing from process I, and J is reaching to process J. So basically P process I, process J, and process J, and this bracket will be MIJ. Okay, so it is saying if send of MIJ like is dependent of send of MKJ, this means if this is dependent on this PK, so MJK, right? So this is what is saying. If this message is depending on this message, then at first the message received at that first message should be received here. अरे क्या हो गया? Sorry. Okay. then the first message should receive at this place, then only it will be received at this place. This is very easy and layman term to understand. This is not something that is new, like we are understanding a very basic understanding. Just it has been formulated in a formula and we are thinking it is something different, but it is exactly the same that we know. Understood? This property ensures that the casually related messages destined to the same destination are delivered in an order and that is consistent with casual relationship. Okay, छोड़ दो इस बात को. I think मतलब बोलते हैं ना, एक intuition है कि this can come in MCQ tomorrow. What is the order of delivery of message? So first of all, or we can say, who is subset of what? So सबसे बड़ा, this is FIFO. Okay, first in first out. In it comes non-FIFO. Okay, non-FIFO. And in non-FIFO, it comes casual ordering. Casual ordering. Okay, understand this. This is written in the PPT. I'm not making it on my own. This, you can see this. Oh, sorry. Non-FIFO बाहर आएगा. Non-FIFO बाहर आएगा. FIFO will be here. Okay, understood? So first of all, it will be non-FIFO, then under it will be coming FIFO, and under it will be coming casual ordering. Understood this thing? Now coming to this next thing. Okay, now we have completed more 5% of the context. Coming to this, a collection of a local state of its component, namely process and communication. ठीक है. Abhi we will be understanding a few things for each from each of the line, and please bear with me for some more time. You will be able to understand it very clearly. So first point says the state of a process. What is the state of a process? है ना, ये बहुत ध्यान से आप पढ़िएगा क्योंकि एवरीथिंग अपार्ट फ्रॉम इट विल बी हैपनिंग, like आगे जो भी स्लाइड्स है, it will be going through this context only. So the state of a process is defined by its processor, रजिस्टर, स्टैक, लोकल मेमोरी, डेटा स्ट्रक्चर एंड ऑल. तो जो भी एक प्रोसेस की स्टेट होती है, what does that state acquire, or what does that state contain? It contains the registered, the stack that are being used, the local memory that is being used, the data structure, xyz things. So this is the state of a process. What is the state of a channel? The state of a channel will contain all the messages that are in transit state. Okay, the things that are in process, the state of channel will say that. The occurrence of event changes this. ठीक है, इसका कुछ context नहीं है. An internal event changes the state, ये भी पढ़ा हुआ है. The send event changes the state of the process. ये तीनों point we have been covered in the first slide. If you want, you can revisit it, but I'm sure this is. Now this is way important thing. Please guys, इसको बहुत ध्यान से सुन लेना, because after this I will be only talking about this LSIX EIX state. So please understand this. Okay, so what this LS determines, LS is basically local state. LS means local state. Okay, local state denotes the state of a process PI after the occurrence of event EX and before EX1. See, understand this thing, what I'm trying to say. ये देखो, this is my line, this is my state EIX, and this, sorry, event, and this is my event EIX plus 1. So after this event is complete and until it reaches to this event, the whole state of the process is known as local state of that particular EIX. Understood? Understood? This is what is been told. Now LSI0 means initial state. Correct, this is the initial state. LIX is a result of execution of all the state executed till EIX. मतलब अगर मैं EILX इसकी बात करूंगा, LSIX क्या होगा? तो from back to this, what all has been done, this is called as local. यहाँ तक, from here to here, what all has been done, all the information will be covered into this local state of LSIX. So LSIX is a result of execution of all the events executed by the process till EIX. अभी ये वाला तो ठीक है, मतलब दिस इज अगेन मैथमेटिकल, आई डोंट नो इट इज इंपॉर्टेंट और नॉट, क्योंकि नहीं समझ में आया तो भी सब समझ में आ जाएगा. ठीक है, so I hope you understood this LS. Now second thing is coming SC, that is channel state, right? So understand this also. हमने पहले local state देखा. Local state is local to a process. Channel state is a state of all the processes. So it says the state of a channel depends on the state of the processes it connects. So let SCIJXY denote the state of channel CIJ. देखो, I am just decoding in front of you so that you can understand this. SCIJXY. See, this channel state will definitely contain two processes. So I will have one process and two process. First will be I, second one is J. I, J. इसको कैसे visualize करोगे? This is I and this is J, right? This is process I, this is process J. Understood? And this X will be for the first process and Y will be for the second. XY is what? Event number. ये कौन सा event है? This is event I and this is event Y. X and Y. Understood? समझ में आ गया आप लोगों को ये चीज? Is it clear? What does this SCI this mean? Are you able to understand this? Or should I say it again? Guys, सो गए क्या?
नहीं क्लियर है.
Clear. Cool. This is what is said. So the state of a channel is defined as follows: SCIJXY message. See, everything that I explained you, this is written here only. So do not need to worry about it. Okay. So there are some things that I have created a note of. SCI. This is clear to you, right? SCI. MIJ means a message from PI to PJ. Okay. Send MIJ. That means the event where PI sends a message to PJ. सेंड MIJ का क्या मतलब है? MIJ का मतलब होता है PI टू PJ के बीच में जो मैसेज गया है. एंड व्हाट विल बी द सेंड मीनिंग? सेंड मीनिंग दैट the event where process PI sends a message to PV will be sent, and what will be the receive MIJ? The event where process PJ receives from PI. चलेगा? ये भी क्लियर है दोनों? And EIX, you know, EIY, you know, formal definition, you got to know, implication, you got to know. Concluded. Okay. अभी अपना कितना बचा है? थोड़ा सा ही बचा, ज़्यादा नहीं बचा है. देखो कितनी स्लाइड्स बची है, बहुत सारी बची है. ठीक है, आई विल रैप इट अप क्विक, आपको भी ज़्यादा टाइम नहीं लगेगा. ओके. Is it okay that we can extend it or not? What you say? We are at 11:30 timing. Whatever you say. Should we like?
No, no, wrap it.
Should I wrap it?
I think to go to sleep. Yes.
Okay, what about others, guys?
Yes, why we can continue.
Okay, I got two answers. Guys, other than these people, can I get some information so that I can confirm what to do? We can.
We can continue. Yes, I think.
Should we? Are all agreeing with this? Who are the all participants? Kanishka, Mayank, Meenal, Mohammed, Nihar, Prasanna, Ritik, and Shubham also. Should we go or what?
चलेगा, extend कर सकते हैं.
Yes, yes, yes. We can continue.
Okay, cool. So yeah, I guess yes, those who like want to drop off can drop off. They can watch the recording later also. So there is no much left and important also. So I guess we can go ahead. Okay. We will be extending this. So what is a global state? Now we understood local state, we understood the channel state. Now the only thing is coming is the global state, and fairly easy. Global state is a collection of all the local states. Clear hai? So what it is? Union of all the local states and all the channel states. The union of both the states will be a global state. Clear है ये चीज? So for a global state to be meaningful, the states of all the components of the distributed system must be recorded in a same instance. Okay, this is not much of the understanding thing, but however, when we will be going ahead, you will understand this all. Okay. So now coming, even if the state of all the component is not recorded at the same time, such state will be meaningful provided every message that is recorded is received as sent. Okay, let's understand this. Okay, channel state again. This one. What is this channel state? Basically, channel state is the change of a state from PI to PJ will be a channel state. So SCIJ and XY what it will be in SC, in that will be two process P and P, this will be I and this will be J, and what this X determined for this process and this process. So event that is on process I and the count is X is like casually dependent for EJ, which is which is present on process J with the count Y. Can you show it? Okay, diagram. Yes, this one. Okay, this one is the state. Understood? So this Pj and Y is P22 and P12 is Pix. ठीक है, समझ गए? Okay, cool. Where I was, yes, here. So basic idea is that each state should not violate causality and effect should not be present without a cause. That's what we are trying to understand from long time, that a message cannot be received if it was not sent. Agar message send in a so how will it will like get received? So this is all the global state and all that we are talking, and it is now making sense that such states are called as consistent global states and are called as meaningful global states. In short, what I'm trying to explain to you is there should not be any criteria where something is receiving before it is being sent. So this is what is called as a consistent global state, as written using like these three lines. If you do not understand it, I'll explain to you again. Just give a shot to it, and then we can discuss again. So inconsistent global states are not meaningful in the sense that a uh, distributed system can never be in an inconsistent state. How should I explain you this? Okay, let's read this line. Okay, let's read this line. This may give you some insight. It says channel state SCIJ and a process state LSJ must not include any message that the process PI sent after executing EJ. This, understand this. This is important. Like this explanation of this is been provided in this slide. So just give me 1 2 minute and 1 2 slides, and I'll be able to clear you this, because theoretically like it might not be able to grasp, but using the diagrams and visualization you will be able to understand this. So see this. This is again a state, and I am saying M12 has occurred before E12. If you say where it M yes. Okay, understand this graph. Okay, let me I think I need to clear this to make you understand. I cannot. Okay, cool. So see, understand this. If I talk about this particular, if I write here, okay, tell me this thing. If I write LS11, what does this mean? LS11, this all state, this complete state, right? Correct. Now think of a scenario. This message has been sent after this thing, right? After this local state is registered. So the message, where it is consistent, how should I explain you? M12 has occurred before E12. This will have only the state till E12, hence it will not record this. Okay, to talk about inconsistent and consistent system, this here consistent and inconsistent global state, let's take an example of this. Okay, to understand this, take this four cases: ls11, ls23, ls33, and ls42. So let's talk about ls11. What does this mean? It means that, like, if you remember this, where it is local state, mm, this one, what I have told in local state, from past to that particular state X, all the information will be stored till here. That will be a local state. After that, there will be no local state for E, like LS11. It will till here. If we talk about this, it may be then LS12. Correct. अगर ये और आगे बढ़ गया, IX2 हो गया, तो it will be local state of 13. Local state means यहाँ तक और यहाँ से पहले whatever information was there will be stored in this ls13. So taking that ahead to this graph, now understand this. ls11 means what? All the information will be till this only, correct? So basically this e1, yeah, local state 1 does not know what is happening with e12, correct or not? Is it making sense to you, or should I
Yes,
explain
yes.
again? Okay, so what I'm trying to say, ls11 means yes, I'll explain it again, don't worry. ये देखो यहाँ पे. Okay, step by step. What is ls11? ls11 is local state at e11, local state of e11. So local state of e11 will be this. हर्षल ये तो समझ में आ गया? Is it clear to you? Cool. अभी एक बात बताओ, in this context, does this local state have any information what has happened to e12? Does it have it? No, it does not have, right? So that's what is written here. If we say ls11, ls23, ls33 and this, so that's what I am written. e12 has occurred after e12, this e12, or I can say e11, and ls11 will only have the information till e11, hence it will not record द रिसीप्ट ऑफ e11. देखो भाई, दो चीजें, यहां से सेंड हो रहा है एंड यहाँ पे रिसीव हो रहा है. सो सेंड की भी एक रिसीप्ट बनेगी कि आई हैव सेंड द इंफॉर्मेशन, एंड रिसीप्ट का भी एक वो बनेगा, रिसीप्ट दैट आई हैव रिसीव्ड द इंफॉर्मेशन. सो दिस पर्टिकुलर लोकल स्टेट will never get to know that this particular send has been done. That's what is trying to like explain here. अभी अगर ls23 का बात किया जाए, where is this ls23? ls23 means e23, e23, correct, e23, and ls33, where is ls33? This one. And where is ls42? ls42, this one. Okay, cool. See this, why is this inconsistent? See this, because the state p2 has recorded the receipt of m12, however the state of p1 has not recorded it sent. See here, p2 कहाँ पे है अपना, ये रहा. यहाँ पे at this moment of time, understand this, I'll explain it to you once again, just a minute. एक बार और अच्छे से देखते हैं इसको, ठीक है? वेट अ मिनट. हमने चार स्टेट की बात करी, आई विल बी मार्किंग दैट स्टेट्स विद अ स्क्वायर, ठीक है? अंडरस्टैंड, आई विल एक्सप्लेन टू यू अगेन वेरी स्लोली. सो दिस इज माय फर्स्ट स्टेप, दैट इज ls11. This is my second step, that is ls23. This is my third step, that is ls33, and this is my fourth step, ls42. ठीक है, यहां तक ये चार स्टेट बना दिए. नाउ सी हाउ द मैसेज इज गेटिंग पास्ड. ओके, सो the first message is getting passed from here to here, ठीक है? Since local state this one has only information till here, does it get to know this has been done? Yes or no? Tell me.
No.
No. Clear है सबको? This is no. ठीक है, बट नाउ सी दिस, जब ये यहाँ पे आया तो इट हैज रिसीव्ड. नाउ will this state get to know that this has been done? Yes. Why? Because this event has been done after this. I told you that this is working in a process. Correct है? Correct है? तो this e32 will definitely get the receipt. देखो भाई क्या होगा, सबसे पहले e11 चलेगा, फिर e12 मैसेज सेंड करेगा e22 को, एंड देन e23 चलेगा. तो e23, this e12, when it will run, e11 will never get to know that it has run, but e23 will definitely get to know because this has happened after e22, right? ये चीज अभी समझ में आया थोड़ा सा? Yes. Now talking about the third case, ls33 and ls24. ls24 या 42 है, यस करेक्ट. अभी ls33 and ls42 को देखो तो ये इंफॉर्मेशन यहाँ के यहीं पास हो रही है, राइट? यहाँ के यहीं पास हो रही है. सो डेफिनेटली बोथ ऑफ द स्टेट्स विल गेट टू नो द इंफॉर्मेशन, बट सिंस ये वाला सिचुएशन में वी डिड नॉट गेट एनी इंफॉर्मेशन, दैट्स व्हाई इट इज इनकंसिस्टेंट. अभी मैं जब आपको कंसिस्टेंट बताऊंगा ना, दैट यू विल गेट टू नो हाउ इट इज वर्किंग. Now let's take the example of ls12. I just remove this up. everything, and I'll remark the steps with a yellow mark. Okay, what are the steps? ls12, ls12 is this step, this step. Okay, second is ls24, ls24 is this step. Okay, ls34 and ls42, ls34 is this and ls42 is this. Correct है? अभी देखो एक बार how easy it is to understand. See, the message is passed from E1 to E22. ठीक है, since we had stored the local of this thing, we know that this message has been sent. Correct है? Still here. After that, this E24 has run. That means E24 has the information. Sorry, E24 has the information that E22 has received the message. Correct hai? Correct. Now E33 has sent the message, right? And if this E34 knows that this has sent the message. Correct? Yes. And in last stage, this has been received to this, and again we know, because this is the current state, that this has been done. So if you see this is a consistent state, because each local state has the information of message being passed and not. Correct है? अभी समझ में आया आपको how it is working for inconsistent and consistent? गाइस आपको इस बार यस, मीनल आपको समझ में आ गया? मोहम्मद आपको समझ में आ गया भाई?
डन भाई समझ में आ गया।
आपको आ गया समझ में? नहीं आया मीनल? ओके, मैं आपको फोन पे बता दूंगा अलग से। ठीक है, चलो। हाँ, क्योंकि वो इट इज अगेन बहुत ज्यादा मैंने ड्राइंग बना दिया, वो मैं ही भूल जाऊंगा क्या बता रहा हूँ। ठीक है, चलो। सो this come to this is the last thing. Okay, this is the last thing, only 5 slides are left, and this is very easy to understand. देखो cuts क्या होते हैं, है ना? Now the last thing that is coming, it's cuts in a distributed system. So what we will be doing, we will be creating a cut. See this is this dot 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 line जो दिख रहा है ना, this is a cut. And what this cut is, a cut slices the same the space time diagram, and thus set the events into past and future. Understand this very carefully. ठीक है? Whenever this cut will intersect the process, whatever has been before this will be a past, and whatever will be after this will be future for that particular cut. बस इतना याद रखो. ठीक है? On this step, on this curve, from here to here will be past, and from here to here it will be future. On this cut, from here to here it will be past, from here to here it will be future. And on this point, for I am talking about C1. Okay, from here to here it will be a past. Yes, and from here to here it will be a future. Yeah, past or future, are you able to understand it? Are you able to understand this, everyone? Yes, cool. Now let's talk about this second thing. Okay, now let's talk about this past and future. आप लोग बताना, ठीक है? आप लोग, like, you try to communicate with me in this second stage. Talking about this cut C2. So this will be the point ahead. Everything it will be a past, after will be a future. This point पे, yes, this is a timestamp. Correct. This will be a past. This will be a future. This will be a past. This will be a future. And this will be a past. This will be a future. ठीक है? समझ में आ गया पास्ट और फ्यूचर? आर यू एबल टू अंडरस्टैंड दिस पास्ट एंड फ्यूचर? This is what has been given. A past contains all the event to the left of the cut, and the future contains all the events to the right of the cut. ठीक है? For a cut C, left paste C and a future C denotes the set of events that have occurred in the past or future of C respectively. Correct है? Okay. Now it's saying every cut corresponds to a global state, and every global state can be graphically represented as a cut in the computation system. देखो, if you are able to understand this, आपका maximum काम हो गया. ठीक है? क्योंकि अभी एक consistent cut आएगा, and this is very easy to understand. Okay, in a consistent cut, every message received in the past was sent in the past of that cut. मतलब क्या है? कंसिस्टेंट का मतलब कि इफ देयर इज अ मैसेज दैट इज बीन रिसीव्ड, सो रिसीव एंड सेंड, दे बोथ शुड बी इन द पास्ट ओनली. ऐसा नहीं होना चाहिए कि पास्ट से फ्यूचर में आ गया, फ्यूचर पास्ट में. इफ इन दिस केस, if you see this message sent, understand this. Okay, understand this very well. Can anyone tell me ये जो E1 है, this is a future or past with respect to C1?
Future.
Future. Correct, future है. Good. Talking about E22, is it a future or past for C1?
Past.
Past. So something was into the past, something was earlier in, like an event was earlier into the future and it came to the past, so it does not make any like consistent cut. So we say this particular cut is inconsistent. Understood? मतलब जो भी मैंने C1 cut बनाया, it is inconsistent in nature. Now let's talk about this one. Not now, let's talk about this particular cut. Can you tell me with respect to C2, I am asking, E24 is past or future?
Past.
Past. And E13 is past or future?
Future.
Correct. So is it possible for something to come from past and go to future? Yes, definitely. यार past से आके future में जाएगा ना, right? So this can be rolled as a consistent cut. Now let's talk about this. What is this? This is future or past?
Future.
This is future or past?
Future.
So future to future is also a consistent cut. Understood? So what this is, what is a nutshell. In a consistent cut, every message received in the past of the cut was sent in the past. All the message that crosses the cut from past to future are in transit in the corresponding consistent global state. A cut is inconsistent if a message crosses from future to the past. जो मैंने आपको first example बताया. Is it clear to you all? Is it clear? Yes. Now, past cone of an event and future cone of an event. Again, it is really easy and like convincing to understand. All events EJ that could have been affected only all the events EI such that EI gives EJ. That is basic definition. अभी past क्या होगा? Past of EJ basically on the point EI. Every event that has occurred before EI is past. That's what it is trying to say. Past of EJ is equal to EI for all EI, where EI is effect on EJ. मतलब EJ बाद में ही होगा. In this case, if we say Lambert's rule, it says EI happened before EJ. So if I say past of EJ, it will be all the EIs from I equal to 0 to I or N. This will be called as a past of EJ. Correct है ये? Is it like, are you able to understand this thing? Yes. Anyone who is not able to understand this? Okay, cool. Okay, now this is the thing. देखो बहुत easy सा terminology है. If this is a process, this is a process line, this is a process line, then and this is my cut. This can be my maximum past. Correct? क्यों maximum past? क्योंकि उसके बाद तो EJ ही आ जाएगा. Correct है? Correct है? And this will be my minimum future. See this diagram. You will understand this. ये पॉइंट के लिए फॉर दिस पॉइंट दिस पर्टिकुलर विल बी द मैक्सिमम वैल्यू ऑफ ई. देखो 3 इज द मैक्सिमम वैल्यू आउट ऑफ 1 2 3, राइट? करेक्ट. सो दिस पर्टिकुलर पॉइंट इज मैक्सिमम ऑफ द पास्ट एंड E43 विल बी मिनिमम ऑफ द फ्यूचर. करेक्ट है, क्योंकि E4 सबसे छोटा होगा, उसके बाद ही बढ़ेंगे. करेक्ट? आर यू एबल टू लाइक अंडरस्टैंड दिस थिंग? yes, no? Cool. I hope you are. This is what is been told here, that let pass E be the set of this. You read it, you will get it. बहुत easy से terminology है. Now only two things more to understand. The max past EJ will be union of all the maximum past that I made you understood there. And again, so max past क्या होगा? Max past consists of the latest event at every process that affected event EJ and is referred to as surface of past cone of EJ. This may be asked tomorrow in MCQ if required. So इसको एक लाइन कल पेपर के पहले एक बार पढ़ लेना. Okay. Coming same. Since as we made it as a surface of past of cone, similarly minimum future will be surface of future of cone. Simple. Very easy to understand. Okay. ये सब वही चीज है, सब एग्जैक्टली वही चीज है, सेम टू सेम. इट इज नॉट समथिंग न्यू. अभी बस 2 स्लाइड बची है. ओके, नाउ कमिंग टू द लास्ट टॉपिक ऑफ दिस कंप्लीट चैप्टर. ओके, that there are two basic models of process communication, synchronous and asynchronous. ठीक है, process communication can work in two ways. अभी synchronous क्या होता है? A synchronous communication model is a blocking type model where a message sent the sender process block waits until the message has been received by the receiver. A synchronous process can be discussed in the way I explained that WhatsApp message wala. Until and unless samne wala will receive the message from me, then only the next message will be triggered. So in this synchronous way, everything will work step by step. First thing will done, then only second, then only third, then only fourth. That means each subsequent process or event will wait for the previous event to complete. This is what is synchronous, and this is written in this particular point. The sender process resume execution only after it learns that the receiver process has accepted the message. That's what I told. Okay, thus the sender and receiver must synchronize to exchange the message. Now, on the other hand, what is asynchronous? Just a minute, let me drink the water. Okay, what is asynchronous? An asynchronous communication model is a non-blocking type model where the sender and receiver do not synchronize with each other. That means after having sent a message, the sender does not wait for the message to be delivered to the receiver. The message is buffered by the system and is delivered to the receiver when it is ready to accept. Understood? Synchronous and asynchronous समझ में आ गया सब लोगों को? Are you able to get it? Guys, just एक slide और बचा है. Just one more. And we are done. See this is the last one. Okay, and this slide just talks about pros and cons of that communication. Okay, so it says neither of the communication model is superior to other. Asynchronous communication provides higher parallelism because the sender can execute message while in translate. Correct. Why asynchronous? Why it is useful? Because I can provide messages without getting the feedback. This way I can establish a parallel communication between the processes, right? However, a buffer overflow may occur. Correct. If I am sending the messages again and again, and if the receiver is not able to receive the message, the receiver can get overload of messages. So this is a buffer overflow situation. Thus, an implementation of asynchronous communication requires more complex buffer management. Okay. In addition, due to higher degree of parallelism and non-determinism, it is much difficult to design, verify, and implement distributed system for asynchronous communication. Meanwhile, synchronous communication is simpler to handle and implement, but there is also one con of synchronous. Since it has to wait for every call, then it decreases the performance. That's what is written. However, due to frequent blocking, it is likely to have poor performance and is likely to be more prone to deadlocks. क्योंकि if in case अगर एक वो नहीं आया, if the message is not delivered on time, then definitely the scenario can occur that deadlock scenario can come. And this completes the whole chapter 2 in itself. So I hope that you are able to get some insights of this chapter. It's not that tough, but just it needs one more reading to get completely inside of the topic, and I guess you are done with the concepts. Fair enough. Anyone has any doubts in the slides? हाँ मीनल आपका मैं I'll discuss to you over the call. I'll make you explain. I'll help you with that. Don't worry. Other than that, is anyone facing any issues in any of? Yes, Bhavesh bhai.
जो गलती से हो गया भाई.
It's okay. कोई बात नहीं यार. ठीक है. So this is the complete thing that will be coming. I have tried to cover maximum of the things. कुछ छूट जाए तो मेरे से भी छूटेगा ही फिर वो. Okay. Okay, guys. That's all from my side today. Thank you so much.
Good night. Thank you.
Yes, Harshal, आप recording stop करके share
Thank you,
कर.
bye. Thank you.
Yes, bro.
Yes.
Thank you, Yash.
Thank you.
Bye.
Bye.
Thank you, भाई.
Good night.
यश स्लाइड शेयर कर दोगे क्या भाई?
हाँ कर दूंगा.